As we discussed in last reactions, the electrophilic substitution reaction of aromatic compounds. Over here, we are going to discuss the next step that is called the halogenation of benzene. As I told you, if you watched the last video, and if you don't, then please go first and watch that, because over there I told you, like, any of the reaction in which when a strong electrophile attack at the benzene ring, then the electrophilic substitution takes place. The weak electrophiles will not take place in the reactions, even to in generally even. So if you want to make it to go further in the reactions, then you have to use some kind of catalyst. So over here we discuss about the halogenations. Even the halogens are the weak electrophiles, so here we use some kind of catalyst. So here this is called the halogenation of the benzene. The need for a catalyst, it is very important, you have to keep this thing in mind. The need for the catalyst. Benzene is normally unreactive due to, because it is very aromatic, and due to aromaticity it is stable and it will not take place any kind of reactions. So to make it react with the other kind of species, or to attack the other kind of species on it, we have to use some kind of catalyst. So unreactive to halogen because they are not strong enough to its aromaticity disrupt its aromaticity. However, halogen can be activated. However, halogen can be activated activated by Lewis acids. So this is called the Lewis acid catalyst, such as ferric halide, that is FeX3, or the X is over here. It could be chlorine, bromine, but generally we use FeBr3 at this place. We talk about it. And the other one is aluminum halides, to become much more powerful electrophiles, to make it much more powerful electrophiles. Here, this is activations of the bromine. How it take place? Activation of the bromine by the Lewis acid FeBr3. So it is the molecule of bromine. It is the Br2 attached with Br, single bond Br. So this is the ferric bromide, and the lone pair is donated into the empty orbital of the Fe, and the compound is formed like this. It has a positive charge, now it's a negative charge. To balance this positive charge, it will break to this side. This bond, this lone pair is shifted to this side, on this is formed. Now it is a negative charge, it is a positive charge. Okay. The bromine chlorine is non-polar. These are non-polar due to what? The same charge of both sides. Like the electronegativity of both the atoms are similar, so these are non-polar. Even all the homoatomic molecules are the non-polars. Here we see non-polars, non-polar, so it is not a good electrophile, or due to this reason it is not a good electrophile. The halogen carrier is required to polarize the halogen. Carrier required to polarize the halogens. To make it polarized, just because of that they become able to attack on species like benzenes. Here we see these activated bromine complex. This activated bromine complex attack the benzene molecule. Attack the benzene molecule, allowing the other bromine atom to depart with the good leaving group FeBr4 का की power minus, like the minus charge is generated on FeBr4 minus. 4bc. These double bond will attack over here. It's a double bond attacks on this bromine, and this bond is breaks to this side. Okay, then it is formed and the positive charge over here. Okay, and it is removed from the compound. We further go, and what we see here, what we see over here, FeBr4 minus next abstract a proton from the cyclohexadienyl cation. The cyclohexadienyl, this is the left proton to again to retain the aromaticity of this compound, of this molecule. It remove this hydrogen, and this proton hydrogen is removed by this bromine atom. So what gonna happen, we see over here the one of the bromine comes and take this hydrogen away, and these bonds shifted toward this, and what we see, this is bromobenzene product is formed, and HBr is removed, and the Lewis acid as it is because it is used in the form of catalyst. So the thing is completed over here, and we study about the kinetics. So in the case of kinetics, what we see, that to calculate the rate of the reaction, the K is the constant, rate constant, the benzene ring, halogen, and catalyst all are used. This is called the rate of the reaction. Now, to understand the reaction, we go through some kind of the calculation to understand the reaction is of endo endothermic or exothermic. The bond energy calculations show that the electrophilic bromination of benzene is exothermic. Exothermic reactions are those in which after the reactions or during the reaction the heat energy or is released. So these kind of reactions are known as exothermic reactions. So what to say, like delta H is positive in this case. So these reactions are known as exothermic reactions. Or in case of endothermic reaction, delta H become negative. Mean during the reaction you have to provide heat to the system, or after the reaction the heat is removed, that is called the exothermic reactions. So what we see over here, this is phenyl H. The one of hydrogen bond is breaks, one of proton is abstracted, so its required energy is 112 kilocalorie per mole. Br bond breaks to 46 calorie. Phenyl Br is formed, so minus 81 kilocalorie per mole is observed, and HBr bond is formed, the minus 87.5 kilocalorie per mole is observed. During the reaction, minus 10.5 kilocalorie per molecule energy is released. So this is called the exothermic reaction. Fluorination of benzene is very exothermic, so it explode. It is explode. Chlorination and the brominations required an activated catalyst. There must be a activated catalyst. Iodination is endothermic and does not occur. This is the endothermic process, iodination, so it is not occur. In the next lecture, we talk about the electrophilic substitution reactions, in which we will discuss nitration. Thank you very much. Stay tuned and watch every video, because I will upload a video every day, and if you find any kind of the complaint you have related to these, then you can write down in comment box, and if you want some other help from my side, then I'm ready for that. You just write down, and if you want any other topic related to this, then please let me know in a comment box. I will do my best and provide you every effort I could really do for you. Thank you very much.